Hello friends, welcome to Susan and John MathTube, and this is the second part of the most repeated questions in higher order derivatives. Okay, so in the last two videos we are learning about how to find the higher order derivatives and the general order derivative, or rather the nth order derivative. So in the first video we learned how to get a second order expression in a very easy manner, and then we learned how to apply Leibniz theorem and find the nth order derivative. Now I hope by watching the first and second video you're okay with the method. Let's focus on more problems in this video. Okay, the first one. So you can write the question and work out along with me. So make sure you keep a pen and a paper with you. So the question goes like this: y is given by x square minus 1 the whole power n. And you're supposed to prove two things. One is our favorite second order expression. It goes like this. Okay, and second thing, we have to apply Leibniz theorem to the first part and prove that x square minus 1 y n plus 2 plus 2x y n plus 1 minus n into n plus 1 into yn equal to 0. Okay, so if you had watched the first video, you will know how to work out the first part. And if you watch the last video, you will understand how to find the general term or the general derivative expression from the first part. Okay, anyway, we will start. By looking at the first part of the problem, we can understand that we have to find y1 and y2. So I am going to differentiate this to find y1. So this is in the form something to the power n. This is in the form something to the power n. So y1 will be n into x square minus 1 the whole power n minus 1 times 2x. I told you we have three enemies. One is fraction, another is square root, and the third one is the given question popping back when you differentiate. And I can see almost something like the given question. Look at this, the given question is x square minus 1 the whole power n. And here we have whole power n minus 1. So I am going to play with it. I think you know the relation a power m minus n is a power m by a power n. So in the next step, I am going to write n into x square minus 1 the whole power n by x square minus 1 the whole power 1 times 2x. I think I'll put that 2x over here. Now take a look at this. We got the question. And I told you, whenever the question pops, when we differentiate, you had to replace it with y. So I'm going to rewrite y1 is equal to 2nx. I just made it n into x. That sounds good. Y the whole divided by x square minus 1, because this part is y. Okay. Not okay. We got fraction. And when we get fraction, what we do is we cross multiply, or we multiply throughout by the denominator, and we end up with something like this. Anyway, there is no square root, so we are ready for the second order derivative. If you are curious why I am differentiating a second time, you can just check the first part. Look at this. We have y1, but the relation is in terms of y1 and y2. Okay, ready to differentiate? So in the exam, you must write differentiating with respect to x on both sides. I'll put two colors for you so that you will be able to focus on the product rule. Okay, I think you can see the product blue into green. So we get x square minus 1 times the derivative of the green one is y2 plus y1 into, what is the derivative of x square minus 1? Come on. 2x is equal to, now look at this 2n is a constant. So I'm going to keep this 2n. But still, look at the last part. We have a product. See, x into y. So we have to apply product rule. So here we go. We get x into y1 plus y into 1. So we are almost done. Now we have to distribute this 2n. So x square minus 1 into y2 plus 2x into y1 is equal to 2nx y1 plus 2ny. Now we are going to combine this and this. We will take everything to the left, and x square minus 1 into y2 plus, you can see that 2 is common, y1 is common. So I'll take or I'll leave it like 2x minus 2n into y1. I think I should have taken that x also outside, 2 also outside. We'll do that in the next step. Minus 2ny equal to 0. Okay, that's it. We got the same thing. They didn't simplify much. Okay, now look at this. Now we have to find the nth order derivative. You can see that very clearly, as I explained in the last video. When you differentiate the second order derivative n number of times, we get yn plus 2. So clearly I have to differentiate this expression n times. But do you remember one very important thing when I when I did that Leibniz thing? That is, the function which will vanish in a few derivatives when you differentiate again and again and again. For example, if you differentiate this y2, it becomes y3, y4, y5, y6, y7. It's not going to end. At the same time, x square minus 1 differentiated will give you 2x, and 2x will be 2, and 2 is literally mathematically dead, 0. So such a function should be written as the second one, plus y1 into minus, here we don't have to apply Leibniz rule because there is no product. Leibniz rule will be applied to find the nth order derivative when we have a product. Okay, now in the exam you can write blah 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 applying nth order derivative or finding the nth order derivative using Leibniz. Whatever you like, you can write it over here. Not whatever you like, something related to the context. So I'll put some colors here. Okay, so shall we start? So you have to write the nth, remember we are differentiating n times. So the derivative will be yn plus 2, and write the second function as such. Now put plus, and then we will put nc1 co n. Then I reduce the derivative by 1, that is n plus 2 minus 1, that will give me n plus 1, and then differentiate the second function, and the derivative is 2x. Okay, again plus, now what we get is nc2, that is n minus 1 by 2. Now reduce the derivative by 1 more, and then 2x. In case you are not able to understand what I just did, I want you to pause the video right now and watch the previous videos. Okay, because I have explained very clearly in the previous video how to apply Leibniz theorem to find the nth derivative. Anyway, that's it. Okay, we stopped here because the second term became a constant. Now we have the next product. Okay, I'll put the color code. let's make it blue and green. So the derivative will be, look at this, we are differentiating n times, and if you differentiate y1 n number of times, you're going to get yn plus 1, and you copy the second function as such. Now you put a plus sign, and then as always that n, look at this, and then what you do is you reduce the suffix by 1, so you get yn, and then differentiate the second one, and that will be 2 into 1 minus 2n into 1. That's it. Now this is a constant, and when you get a constant, you have to stop applying the process, because in the next time you will get plus 0, plus 0, plus 0, plus 0, etc. Okay, now look at the last term, and here we cannot apply Leibniz theorem because it is not a product. It is not a product of two variable functions. So we conclude this by 2n into yn is equal to 0, because 2n is a constant, and when you differentiate this again and again and again and again, we get y1, y2, y3, etc. up to yn. Okay, now the last part is very easy. You write the terms along with yn plus 2, and then comes yn plus 1. Here we have yn plus 1, so two terms. So let's combine, and we can see that we have so many things in common. So I'm going to write yn plus 1. In a bracket I will write 2nx plus 2x minus 2nx. So this will get cancelled, and now the last one, that is yn. So here we have this one, 2, 3. So we have three terms. So let's take yn common. So I can see that this 2 and 2 will get cancelled. I get n into n minus 1 from the first term, and from the second term I get 2n minus 2n square, and from the last term I get minus 2n is equal to 0. So these two will get cancelled, and one more step and we are done. So x square minus 1 yn plus 2 and plus 2x yn plus 1, and look at this n square minus n minus 2n square, it's going to give you minus n square. So you can take common, so that's going to give you n plus 1 into yn equal to 0. I think now you have a clear idea what to do. So let's go for the next question. Okay, so the next question is y is equal to e to the power a tan inverse x, and we have to prove that 1 plus x square into y2 plus 2x minus a into y1 equal to 0. And the second thing that we have to prove, 1 plus x square into yn plus 2 plus 2nx plus 2x minus a yn plus 1 plus n times n plus 1 into yn is equal to 0. So we have y equal to e to the power a tan inverse x. So clearly, as explained before, I am going to find y1, and what I see here is e to the power something. So e to the power something differentiated will give you e to the power the same quantity times this becomes a into 1 by 1 plus x square. Now look at this, we have to look out for three enemies: fraction, square root, and the given question might pop up. Okay, here. The given question is e power, okay. So I'm going to write this as y into a by 1 plus x square. I see another enemy, that is fraction. So we get 1 plus x square into y1 is equal to a into y. Now we don't have fraction, we don't have square root, we don't have the given question as such. So we are ready for the next derivative. So in the exam you can write differentiating throughout with respect to x. We get 1 plus x square into y2 plus y1 into 2x is equal to a into y1. That's it, done. That is pretty easy. And now what we do is we take all those quantities to the left hand side, and as you see y1 is common, so I'm going to skip that step. So I'll write 2x minus a into y1 is equal to 0. You can confirm it. That is what I wrote earlier over here. Now the second part. Those who watched the last video will understand that to apply Leibniz theorem, the most important thing is the vulnerable function, that is the function which will disappear after a few derivatives should be taken as the second function of the product. So I am rearranging the things so that we can apply Leibniz theorem. Okay, that's it, we are ready. So as I told you before, in your exam please make sure you write differentiating the above expression n number of times with respect to x. This is very important. Your presentation is very important in exam. Okay, so let's apply. And as always, I'll put the colors blue and green. Okay, so let's start. So y n plus 2 into 1 plus x square, that is, you're writing the function as such. Now you know what to do. You put n, reduce this quantity by 1 and differentiate the second. Again n minus 1 by 1 into 2, reduce it by 1 and differentiate. And stop when we get a constant. Okay, now we are ready for the differentiation of the second one. So again we have a product. So plus yn plus 1, copy the second function as such, plus n into, you can reduce the suffix by 1 and the derivative of this part is 2. So stop is equal to 0. That's it. Now it's time to rearrange. So there we have 1 plus x square into yn plus 2, and the next thing is yn plus 1. So let's take yn plus 1 common. You can see the remaining part is 2nx, and here you can see that 2x minus a. And now the remaining part is yn. Mark it with red, only 2 terms, and this 2 is going to get cancelled. So yn times n square minus n plus n into 2 is also there, so is equal to 0. So this is going to be n square plus n. You can simplify the rest. So let's go for the next question. So the third question is, okay, it's a little bit special. The question is y is equal to sin inverse x the whole square, and you have to prove two things. The first thing, 1 minus x square into y2 minus x y1 minus 2 is equal to 0. And the second thing to prove is 1 minus x square into yn plus 2 minus 2n plus 1 x yn plus 1 minus n square into yn equal to 0. Why I call it special is, in examination I have seen that many students get confused how to find the general derivative of 2. Now look at this. If you know that the derivative of a constant is 0, that means even if you differentiate this 2 one time, the answer will be 0. So if you differentiate it 2 times or 3 times or 4 times or 1 time or whatever, the derivative will be 0. So remember, when you apply Leibniz theorem at the last, you can write the derivative for this part to be equal to 0. Anyway, we will come to that. So we have the function. Now I think we have to go a little bit fast because it's the same thing. So something squared, so we get 2 into sine inverse x into 1 by root under 1 minus x square. Okay, now our enemies are fraction. I can see a fraction. Square root, I can see a square root. And the given function, I can see something like the given function. So anyway, I'm going to square on both sides because I want to get rid of that square root. When I square on both sides, I get a surprise. The given function popped up. Okay, no problem. So let's get rid of it by replacing it with y. That's it. Now the last enemy, fraction. So we are ready. Now let's apply product rule. Not Leibniz rule, just product rule, simple product rule. So 1 minus x square into 2 y1 y2 plus y1 square into minus 2x will be 4 into y1. Now divide throughout by 2y1 because in most of the problems I have observed that 2y1 is a common factor. Anyway, that's it. That's the end of the first part. We get 1 minus x square into y2 minus xy minus 2 equal to 0. Now what should I do? Yeah, I have to put the products in such a way that the function which will disappear after a few derivatives will come as the second function of the product. Okay, so here we go. I'll put the color code now itself. Okay, let's start. So the first product is light blue and light green. So in the exam you can write blah 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 applying Leibniz rule. Don't forget that. You have to make your answer paper a little bit spicy. So yn plus 2 into 1 minus x square plus n, reduce it by 1 minus 2x plus n minus 1 by 2, reduce this by 1 and then minus 2. Minus in a bracket. Whenever there is minus, it is always safe to put a bracket. So we go for the second product. Yn plus 1 into x. N, reduce, differentiate. It's a constant, so stop. And I told you the logic in the beginning itself, that will become 0. That's it, we are ready. Now simplify a little bit and write the final answer. So we get 1 minus x square into yn plus 2. Then this is common, so I can see that yn plus 1 is common. So 2n plus 1. And here I see yn common. So minus n minus 1 minus n. You can see that there is a minus which goes inside. Yeah, that's it. So minus n square plus n minus n. Yeah, that's it. Now you simplify and you get the answer. Okay, now I'll go for a really weird question. It's kind of like weird compared to the previous questions. So it's given that y is equal to e to the power x square. And they're asking us to prove that only one question. n minus 1 equal to 0. Okay, I can see that by inspection they found y1 and then they differentiated it n times. So shall we start? So once more I'll tell you, the hint is, I can see very clearly they found y1, the first derivative, and then they applied LEIBNITZ theorem and differentiated it n number of times. Let's give it a try. So y is equal to e power something times the derivative of that something part will be 2x. That is y1 is equal to, the given question popped up, so let's call it y into 2x. Now that's it. Let's give some colors and let's write applying LEIBNITZ theorem n times. I'm 90% confident that we'll get the answer. Let's give it a try. So when we apply LEIBNITZ theorem for the left side, it becomes y n plus 1. And here we have a product. So yn, copy the second function as such, plus yn minus 1. Oh, I forgot that n. And the derivative of the second one, 2. Done. That's it. Come on, that's it. So look at this. So we get yn plus 1 minus 2x yn minus 2n yn minus 1 equal to 0. The question looked weird because it's something like outside the pattern which they ask regularly, but the process is extremely simple. Now I want you to get, I want you to go through this question. So please write the next question. If y is equal to sine in bracket, that is the argument of sine. Remember, the function sine becomes meaningful only when we put the argument theta. So here you can see the argument is m sine inverse x. Then prove that y2 into 1 minus x square minus y1 into x plus m square into y equal to 0. And the second one, 1 minus x square into y n plus 2 minus 2n plus 1 into x y n plus 1 plus m square minus n square into yn is equal to 0. So this is a very, very special question, and if you know the trick, you can tackle it very fast. The trick is very simple. Take sine inverse on both sides. Look at this, we are given y is equal to sine the argument m sine inverse x. So what I'm going to do is I'm going to take sine inverse on both sides. So I get sine inverse y is equal to, this becomes the identity function m sine inverse x. That's it. Now I'm going to write differentiating throughout with respect to x. The derivative of sine inverse y is times y1 is equal to m into 1 by root under 1 minus x square. As I always say, after we find the first order derivative, look out for fraction, square root and the given question popping back. So I'm going to square on both sides. Now I'm going to get rid of the fraction. So 1 minus x square into y1 square equal to, remember m is a constant. Unless otherwise specified, you should treat the letters a, b, c up to lmn as constants. So that's it. Now I'm sure you will be comfortable with this. So we get, now we are differentiating 1 minus x square into 2y1 y2 plus y1 square into minus 2x is equal to m square into minus 2y y1. And as I always say, 2y1 is a constant. Cut, 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 cut. That's the answer. And y1 into x plus m square into y equal to 0. Now I'm sure you'll be able to tackle the second part. Try it. As a student, it's very, 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 very important that you practice more questions. The more questions you practice and attempt at home, you'll be very happy on the exam day. I know it's only for 5 marks, but that is how we make our 5 marks safe. You have to practice, 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 practice till you're like saturated with such problems. Anyway, I'm not going for the second part, so you can try it yourself. It's not hard. And we will do one more question. We will discuss 1 or 2 more questions and stop. And in the next video, I am planning to put asymptotes. Okay, so another question is like y is equal to log of x plus root under a square plus x square, and to prove blah 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 etc. Anyway, I will derive half the steps. So y1, look at this, I can see log something. I'm able to see log something. You know the derivative of log x is 1 by x. So log something, the derivative will be 1 by the same quantity times the derivative 1 plus 1 by 2 root into 2x. That is y1 equal to x plus root under a square plus x square, and when we take LCM we get by root under a square plus x square. So that's very interesting. Now everything get cancelled and we get 1 by root under a square plus x square. That's it. Now our number 1 enemy, square root, and enemy number 2, fraction. Now enemy number 3 doesn't exist, so ready to differentiate. So let's go for our colors. Okay, so a square plus x square into 2 y1 y2 plus y1 square into 2x is equal to 0. Now divide throughout by 2 into y1. 2 into y1, and you will get the expression. Now apply and enjoy. So that's it. There are a few more questions which you can go through the past year question papers. Anyway, I'll be back with another video very soon. That will be asymptotes. And asymptotes is like one of the most repeated questions. They had been asking questions based on asymptotes consistently. You can check a few past paper question papers and you'll see that there is not even a single question paper without asymptotes. Anyway, if you like this video, please share it with your friends and subscribe. Okay, so we'll meet soon. So till then, bye.